as I'm fiddling around here, it's going to be fun to go over this because this is something I've been spending the past year or so with a colleague working on. And the reason I've been focusing on this issue is because I spend a lot of time talking with large organizations, and I think I talk with large organizations about how they're getting better at software, which is a simplified way of saying, organizations that write and run their own software and use it, whether it's as their primary business to work with their customers or the citizens that they're doing it for, or as one of the primary ways to run their business internally. I mean, I think of all the people that I would talk about this with, people at this conference understand that software is how most organizations run nowadays. It's vital for doing that. But anyhow, as I'll get into, as these organizations are getting better at software, what they very quickly find themselves in is what my co-author Mark Zotner and I call the legacy trap, which is all of the existing software that they have starts to hold them back and slow them down, as I'll get into. And so this is a talk that goes over a booklet that we worked on, and kind of gives a summary of how people can escape that trap. So there was already a good introduction there, but let me move on to here's me. You can see another picture of myself. I made sure to wear the same shirt for this talk, if you want to check. But as mentioned, I'm pretty lucky in my career where I am. I get to speak and talk with a lot of people at large organizations, mostly nowadays, but people who are inside organizations that are doing exactly what I was saying, writing and running their own software, and the people managing it and people using it, which I think I really enjoy, having spent the first part of my career as a programmer. I've always been in the tech industry at online banking places and systems management software places. And so it's really nice to be able to talk with, normal people who don't sell software as a living, and instead are the programmers who are helping run the rest of our lives instead of just whatever wacky little applications that I work on. But anyways, I document a lot of what I found over the years in those conversations in these books here, which are easy enough to get a hold of if you're interested. Most of them you can actually get for free, thanks to my company. And as mentioned, there's several podcasts and things like that I do. But enough about me. So what I'm going to go over, this is kind of a gigantic summary of the endpoint that we'll get to, and then I'll kind of start from the beginning. But I have worked at VMware now. I started working at Pivotal, which VMware acquired. And it's another thing that I've been really lucky with. I started there almost 8 years ago now. And we have all sorts of stuff going on. But what's relevant to what I'm talking about here is we've had a practice for a long time where we work with people. We do pair programming, if you can believe that, actually pairing up. And we've done a lot of application modernization projects, not only for one application, but portfolios of them. And as the people working on this have done this, they've developed this methodology that's called the SWIFT methodology. And the focus of it, as you can sort of, I'll get to it more, of course, but as you can sort of see here, it's this really great methodology that focuses on getting started and doing small things quickly instead of doing huge things slowly, if that makes sense. And it's well documented out there. Anyone can use it as a methodology. I guess you can't click on that link now, but once you get the slides, you can click on it, and it's easy enough to get to. But the focus, what I like about it is that it does come with a lot of sort of technical tips and directions, kind of like cookbooks and things like that. All the things that you've probably heard about when you're modernizing an application or, as they say, strangling a monolith or whatever. But it starts off with what is, I think, a pretty, maybe not super unique, but a unique enough focus on figuring out how to select what to do, the way that you go about deciding what to modernize, when to modernize it. And in doing so, I think ultimately, like all good methodologies, whether it's like extreme programming or agile or design-driven methodologies, it starts off with the goal that what we want to end up with is software that's useful. We want to kind of get to the point where we are really focusing on, is the software that we're ending up with something that is going to be help people out, that'll help the business or the government agency run better, that'll help employees operate better. And it's focused on the people using it. And as we like to say in business jargon, the outcome. And so that's that for me, not being extremely technical anymore. Unfortunately, it's not programming as much as I used to. I'm always very interested in the sort of why, the outcome that drives people towards it. And so as we'll get to, you'll see how that kind of focus of we're focused on producing useful software that will allow people to accomplish whatever goals they have. You'll see how that's the kind of guiding light, if you will, the thing that pushes along a lot of the steps in the process. So, as I said, let's kind of start from the beginning, right? To establish the importance of escaping the legacy trap of doing application modernization. And these are just, I mean, anecdotally, I think everyone encounters this, right? That and I'll get to a fun couple of examples throughout here, but you know, unless you're working on a brand new piece of software and you have nothing else in your portfolio, which is often the case with a lot of startups and tech companies. So it's often a little wise if you're working in a large organization that's been around for a while to take their advice with a little bit of perspective on the fact that they have very little existing IT and applications to deal with. But you encounter this over and over again, and I certainly do, that when you go talk with the people who own the businesses and their organizations, not the IT people, but the people who are running the business, and also the higher level executives in IT, pretty much all of them will say that the software that they have, their legacy software, is preventing them from moving forward, preventing them from not only creating new applications and services, but also just adding new features to the software that they already have, right? And I'm sure in your day-to-day life, you've encountered software that probably is a result of this, where it seems like it hasn't been updated since maybe like the days of like Flash or something like that. And it seems quite archaic, and it can be frustrating, especially if you're, a programmer or anyone in the technical world, to think like, I don't understand why this application is so old and no one has updated it. Now, there's all sorts of reasons, as we'll get into, but one of them is very genuinely that it's very difficult because you're dealing with so many old applications and so many old services, and the organization hasn't seen fit to take the time to update those old services, the legacy software, which then eventually, there's this term technical debt, right? Like the technical debt that you have, the ignoring your existing software and not maintaining it and making sure that it's well exercised and flexible, eventually that catches up with you and you get caught in this trap that many people in the survey and anecdotally say that they're in, right? Where they can't update their software. So what does it mean for what is legacy software? I mean, I think we probably all have a pretty good idea what it is, but I want to put out kind of like two types of definitions, right? And the first one is from Ann Thomas over at Gartner. Great. I've known her for a while. She's always done good work. If you remember SOA, she was one of the people who first started talking about that and kind of explaining why it was valuable and platform as a service and on and on. So she's always very insightful about these things. And I think she summarizes up kind of my take on legacy software well, right? That it's almost any type of software that you have that's slowing you down and making it so that you can't not only add features to the software or do new types of applications or add new services that you want. But again, it directly connects to and therefore you can't really change how the business functions, right? And since software is core to how most organizations work, if you think about it, if you can't change your software, the business also can't really change how it functions very easily, right? So the software very directly, your inability to change and evolve the software kind of brings your organization to a halt. And I had to renew my son's passport recently with my country's State Department. And you can tell that they are somewhat caught in a legacy trap, because I think I had to actually print out some paper to do things. It was a bit of a ridiculous process. But you always encounter this kind of software where you can tell the organizations, the processes you have to do are held back by the old code. Now, there's a much more simplistic, very extremely clever programmer view of what legacy code is, all the way back from, I think, 2002. And I think the conciseness of this is a very bottoms up precision about it, which is that legacy code is any code you have without tests, right? And so as with any super concise thing, you've got to, as they say, unpack that. And that gets to my kind of jokey way of thinking about it, as you see in the title there, is that in general, legacy software is any software that you're afraid to change, but you have to change, right? And the reason I put it that way, and also it kind of is the silly version of the test thing, is that if there's software that you have to change and you're not afraid of changing it, you don't call it your legacy software. You just call it your software, right? There's no distinction of that of being old or something, right? So it's only for lack of tests, because you can't verify that a change has broken it. You can't verify that if you touch it and change it, then it still works, right? I mean, that's kind of the lacking test part of it. But it also brings in that fear that like, we really don't want to change this. Either we don't know what to do, or we think it might break something. We just don't touch it. And therefore we kind of live by the constraints that it gives us. So that's hopefully gives you kind of like a couple of ways of thinking about what legacy software is. And then to start off with an example, right, to kind of drive this home, like, in the book, Mark and I wanted to come up with an example of how legacy software prevents you from doing the simplest things possible, right? And, back when I programmed a lot more, my recollection was that pretty much anything that you wanted to do, a programmer could just do in 15 minutes, right? Like, of course, that's a joke, but, it's a common saying among programmers that like, just give me a weekend and I could code that, right? Now, experienced people know that is often not the case, but definitely it's a good way of illustrating how having being caught in this legacy trap can slow something down, right? And the example that I was thinking of, because this happened to me a few years ago, is let's say that you go to the beach and you've got your phone in your pocket and you forget that you have it there, and so you sit down in the ocean for quite some time, and then you stand up and you realize you've ruined your phone. I guess nowadays you might be lucky, but several years ago, they were not so waterproof. Now, there's a whole business called the insurance industry, and that is a kind of situation that they would love to get access to as far as a business, right? If you think about most insurance companies, they've been around for 20, 50, maybe even 100 years, right? And they have probably over the course of their life found all the business that they can. I mean, there's only so many homes to insure, so many cars, so many sort of liability, families to sign up for liability insurance. So insurance companies are always on the lookout for new markets, new things to sell into. So many insurance companies have this idea of just like a 24-hour insurance market, right? That I just bought some of this for a rental car recently, but I know I'm going to go to the beach. I just bought a brand new phone for some insane amount of money, and I just want to insure it. Now, chances are high that I'm not going to ruin it. So this is a great business for an insurance company, right? It's more or less free money that they're going to be making. Insurance is a fantastic business in that respect. But so if you think about it, if you went to the programmers with this idea, I mean, you're going to need some software for this, right? And it's probably only going to take a weekend to make the website or even the app that allows someone to sign up, that kind of looks up and estimates how much they're going to charge. But, then they're going to need to integrate with the backends for the insurance company, right? Which is probably maybe a mainframe system somewhere. So they're going to have to figure out how their brand new application is going to be able to get access to that, how they're going to authenticate to it, how they're going to stick into the compliance process for it. And, on and on and on, right? Like there's all these systems that have been working for a while, have helped the insurance company out, but haven't really been maintained and kind of put in a state where they're ready to be used for new applications. And I've seen this happen over and over again, right? Where whether it's wanting to add a new type of business and therefore add some new software or just add a new feature to something, or as we'll see in another case in a little bit, whether it's because there's new performance demands, there's a lot more success in the business and therefore more people are using your software and it's just not performing well, because you've kind of let the back end, the services, all of your old software kind of mature and ripen, if you will. You're kind of caught in this trap that you can't just do this 15 minutes of coding, this weekend work, to do what seems super simple, right? Now, if you think about the scope of this, right? Like there's an estimate from IDC that there's probably, 500 million applications like this, right? 500 million applications that could be considered legacy applications that haven't been modernized running across the world. I don't know what the count is for low Earth orbit in the galaxy, maybe there's a few still running on satellites, but let's add in maybe 5, maybe 2,000 more. We can just still call it 500 million. But if you think about it, and this is why I'm so interested in this topic, is we have a lot of work ahead of us. Maybe we don't need to modernize all those applications, but that sheer amount of applications is going to have a huge effect on our ability as a whole, right, to kind of evolve the software that we have, and therefore evolve the businesses and our very own lives to be dramatic about it, right? I mean, you think back to the passport application, right? Like a little bit of just 15 minutes of coding could have made my renewal process for my son's passport a little bit better. So what we have up to this point is an idea of, what legacy software is, why it's such an important topic, right? Like it's not only frustrating as a programmer, as an architect, but it frustrates the business and therefore the customers or the citizens of that business as well, right? And the magnitude of it is immense. There's like so much of it out there that it's going to become more and more of a critical issue to look at. And so getting down a little bit from it, right? So what does all of this mean? Like what does this happen, right? So this trap, it kind of starts to bury you in all sorts of issues that you have. So it means that you have, obviously, as I've gone over, you have this technical debt, these decisions that you've made, shortcuts that you've taken in order to kind of ship your code or in favor of other things. And eventually, and this is why the debt metaphor works, is that the interest, metaphorically speaking, that you pay on the debt becomes, all that you focus on, and it starts to slow you down. And this means that because then you have to shift over to doing most of your effort just to keep things up and running. Maybe you've lived through this cycle where it takes forever just to upgrade a version of a framework or a service, or even worse, a language runtime you have that you've kind of not been doing for many, many years. And now you've got to slow everything down just to upgrade that the version of your language or your database or whatever you may have. And then also what tends to happen with this is, if you think about when you're caught in this trap, like it starts to add a whole lot more process around stuff. So think to that Michael Feathers thing of like, you have untested code, right? You fear changing this. So you start adding a lot of governance that anytime we're going to change or use something, we're very afraid of what's going to happen. So we're going to add a lot of process around it to make sure we hopefully don't make a mistake and we catch the problems with it. And then also what ends up happening, like is you ignore the code that you have, you also tend to kind of forget and lose skills about what's happening, right? And this is especially true with older systems, right? Where you just can't find people who know not only like how to use that programming language, but who lack the knowledge inside your organization of how it works and what it is, like all of that stuff that's trapped in someone's head, right? So all of these things kind of start to snowball over a while, and these are kind of the attributes that you start to see, right? So as you start to smell out and sniff out, the kind of things trapped in the legacy trap, these are attributes that you start to see with it. So then getting down a little bit more. So what makes something, like, how does the software go bad, right? And I think, overall, I mean, obviously the answer is neglect, right? Like you're neglecting keeping it in good shape, whatever that may be. But I think there's 3 main things that Mark and I kind of decided on and went over. And that is, it's either the software has either been forgotten, it's no longer fit to perform a job, and it no longer has the capabilities that you need. And so let me talk about each of these 3, because this starts to get to the point where you're figuring out what you should do to escape the legacy trap. So I've kind of gone over forgotten already, right? This is one of those things in software, as in so many things. One of the, you could almost call it the dangers of success, is that if you have a really good piece of software, a service, let's call it a system that's running, right? And it works. And it's also driving, millions, if not billions of revenue, euros of revenue or dollars or whatever you want to work with. It's seen as like successful, and you kind of stop worrying so much about it if it just works. And I think this is why you see a lot of things, for example, mainframe processes around still, is because they work and they're directly attached to making companies lots and lots of money, or the organization's function, right? And so it's almost like the more successful something is, the less you over years pay attention to it, and the easier it is for it to sort of be forgotten about as far as the skills that you have. Now, you also might forget about it just because, I don't know, you're negligent about it, right? Like it may be some small minor thing that you don't really worry about, and you kind of are neglecting it. But then also what comes with this is people, people coming and going, whether they're retiring or they're moving to another job, and you just lose the skills and the knowledge to deal with those systems and that software as well. Now, the next area, and I'll go at the end, I'll go over another example that is fixing this fitness problem of legacy software. And that is the fitness of it isn't up for what you need. And this means it doesn't perform well, right? And typically this is that, you either get a lot more demand, a lot more people using your software than you're used to, or you have different expectations for latency. It needs to act faster. This is something that we saw a lot when applications shifted to mobile applications. And when everyone was working at home, over the past 3 or so years, this also exposed a lot of fitness problems that many different systems and applications had. They just weren't used to that load and the latency expectations. And this might also come in the form of the security requirements that you have don't work. If you're worried about sovereign cloud stuff, it may not work anymore. There might be new requirements that come along for your system, and it no longer no longer supports that type of thing, right? And so those are we think of that as fitness, but you can think of it as sort of like the requirements or the performance of it no longer is up for what it needs to be. And then finally, the other way that software goes bad, that it kind of becomes legacy software, is it no longer has the capabilities that you need. And so capabilities, they could be anything, right? Historically, the one that I think of the most is when all of a sudden every application had to become a mobile application, or at least you needed a mobile web interface for it. And just there were many applications out there that just were incapable of doing that. Just the way that you would represent an application in a mobile application, or the way that you would move from, you would move back to kind of like a thick GUI model of a mobile native application just wasn't possible. Oftentimes the way that you might authenticate and the way that users might use software, especially internal software, kind of like on their own devices or outside of the corporate world, doesn't necessarily fit here well. Or it could just be something more simple, like you would like to log in to your software with biometric face recognition, whatever it may be. Just the software that you have no longer has the capabilities that you need, and it can't really support the new features that you want to add into there. So when you find that your software has kind of gone bad, that it's legacy software, these are the kind of, it's always fun to begin your prescriptive words with the same letter, which we've managed to do here. But over the past several years, people have come up with several R's of what you do, right? So the response is, how do you fix this problem? And I think originally, it might have been Richard Watson at Gartner in maybe 2018, and maybe someone even before him who came up with 5 of these R's. And they've been since kind of evolved for a while. But when you come to accept that you're caught in the legacy trap and you need to modernize some applications, the next step to think about, and again, have this view of our goal is not just to rewrite this COBOL application in Go or Java or whatever, right? Our goal is to make sure that the reason, the outcome this software is doing is good and valuable, and we can evolve the purpose that it has, right? And so what you want to do is you want to go through all the options kind of driven by that of what you can do. And so in general, these are the 7 options that people have, the 7 things that you end up doing. Now, the first one, I always joke that my favorite thing to do is to do nothing. I love a canceled meeting, or if there's some work that someone else does that I don't like to do. And it can be, I'll get into how you evaluate this, but it can be advantageous. It may not be worth your time, even if something's legacy software, to actually do anything to it. You might have other priorities, as we'll get into, so you can retain it. Now, another great thing, is oftentimes what you find is that something actually isn't needed anymore, so you can just get rid of it. Now, another very popular one, especially over the last 10 or so years, And this is, there's especially at my company, at VMware, there has been a lot of genuine improvement, a lot of cost savings, even efficiencies introduced by simply rehosting things, right? Moving them to a different place where you're running them, whether it was, long ago virtualizing everything so that you could either move it to, it being virtualized or completely move it to a different hosting scheme where it might be. But you can still, without actually changing the application, you can escape out of the legacy trap a little bit if what's holding you back is the infrastructure, the way that you're running the application. And then there's replatforming, which gets us a little bit closer to more heavy duty modernization, right? Which is you're changing maybe not what the application looks like, probably not even what it does. But again, you're kind of going up, for example, from the infrastructure of the operating system layer and thinking about how can we upgrade or improve the kind of the frameworks, the runtime environments, the platforms that this relies on, right? And so this is another consideration to have. And then finally, we get to the last two options, and this penultimate one, the refactor or rewrite one, is a lot of what I think people think about when they think about modernization, which is, to be very correct in definition, right? Like if you refactor something, its outward appearance, what the application does, its functions, maybe even its UI, it doesn't appear to have changed to a user of that piece of software, but you've done a lot of work to change the innards of it, right? And this is especially attractive if the software is no longer fit, like it doesn't have fitness, the performance characteristics that you need, if it doesn't have the capabilities that you might want in the future, so you're adding new things underneath it, or especially if you've kind of forgotten how it operates, right? Like, and this is where things like the strangler pattern, where you essentially are slowly replacing the older system you're relying on with a newer system through some exciting load balancing and facade kind of tricks, which is great stuff underneath there. But then finally, the one that I think is kind of the highest risk, the most expensive, but tends to have the highest payoff is just rewriting it. And this allows you to directly not only fix the code, but address that why question of, well, why does this software exist? How can we make it better? How can we help the organization out with it? And you kind of start over again, and you're given the chance to improve, not only improve the code and the services that it relies on, but also change what the nature of the application is to really modernize the feel of it. So how do you go through deciding which of these that you're going to do? So what in the Swift process, right? And what we've seen over the years is that, as I've kind of mentioned several times, it's really good to focus on the kind of the whys of it, the outcomes, as I keep saying. Like even if we could just rewrite this into a new language, we could make the UI look better in an organization, unless you're just doing hobbyist stuff, right? Like you want it motivated by some sort of let's call it like a business reason, some reason aside from just the joy of coding. And in general, I mean, there's more of them, but you can see we've done the trick where we start everything with an S. But I think there are several motivators and ways to think about how can we select which applications to modernize and what to do. So the first one, I mean, savings is always important, right? Like if you can present and if you can get some savings by doing something, spending less money basically to do the same, if not, as the jokey phrase goes, to do more, then that's going to be a heavy weight on deciding what you're going to do and which applications you're going to modernize, right? And as an example, there's one another insurance company who did go and modernize went through this process and modernize their mainframe application. And I think they had a savings of like maybe 10 to 15% in addition to the functionality that they wanted, right? So there tends to be savings that you can address with this. Now, security, as I mentioned, is also another issue to look at, right? And often what this means is the ability to identify and deploy patches and deploy new versions, right? So the longer that you let your software kind of sit and not be updated and modified, the less secure that it tends to get. And then there's stability and scalability. Again, the performance characteristics that you have, right? So like I said, in the last example that I'll go over, their primary motivation was that their application, their old applications and the systems they were relying on just couldn't scale to the new needs that they have. So that's another kind of axis to evaluate what you're doing. And then the last two are closer to what developers care about, and that is speed. And speed in the sense of your ability to pretty much release your software more frequently, right? And this directly affects that ability for your organization, for the business or the government agency to evolve, where the more, in general, there's always exceptions to this stuff, but in general, the more frequently you can release your software, even just a small amount of software, the better you will be, that the more frequently you'll be able to evolve the business. And not only by adding new features, but by experimenting and learning which features work, right? So I always recommend, if you can release just a little bit of code every week, or maybe every 2 weeks, and you put in place a very design-driven experimentation process where you're trying to discover the best way to solve a problem, or even what the problem is. If you have that speed of release, you're going to improve not only, like, let's call it the integrity of your software, the goodness of it, but you're going to improve the usefulness of the software, right? It's actually going to function and be useful for people. And this leads on, and this is one that my co-author Mark was always very emphatic about. I tried to delete it out of our book at some point, but he thankfully brought it back in. Is that, you know, it's not fun to be around legacy software, to be caught in the legacy trap, right? You want to, as a developer, as an organization, you want to feel like you have a certain amount of flow going on. You're not kind of trapped working with these old systems. You can't add new features, right? So there's a huge degree that's easy to overlook of just happiness and joy that comes with having more modern software, that you're not kind of trapped using old things. You can't evolve the software. You can't get these other things. So, and this has a direct effect on you know, people's morale and happiness at work, your ability to not only keep employees that you have, but kind of add new skills, try new things, get them to be curious and innovative, attract new staff that you have. But, you know, happy programmers tend to be better programmers, right? I don't know about you, but I remember when I didn't like what I was working on, and I was kind of in an upset state of mind. It's not like I made sure the code I was writing was perfect. I just made sure it passed the tests. But I didn't make sure that it was useful all the time. So, you know, just like anyone doing work, the better mood someone's in, it tends to be the case, the better results that they'll get from their code. So with that framing, like, so these are some characteristics. Again, and what we're doing here is we're trying to figure out what to modernize, and we're putting together a plan for it, a strategy, if you want to get fancy about it. So what you end up doing, and again, this is mostly for organizations that are larger and have a lot of existing software, right? If you've only got, like, if you're like one of these newer companies, you know, a new tech company or a startup, and you've got like 5 to 10 applications, you kind of don't, you know what you need to do. It's a lot simpler and straightforward. But what the modernization method that we've worked on for a while, and kind of the Swift method starts with is, I mean, of course, you're going to have a 2x2, right? And what you want to try to figure out what to do is you want to use, this is called the Eisenhower Matrix, named after our president. And the point of the Eisenhower Matrix is to realize the difference between urgency and urgent and importance, right? And you can kind of see here, you want to start thinking about kind of along those 5 attributes, or whatever attributes you want. You want to start categorizing the applications, the things you might do in this this 2x2 chart, right? Because what a lot of people spend their time on is things that are urgent but not important, right? Or that are important but not urgent. And so you want to make sure that you don't get trapped in one of the blue, the red, or the yellow things here. That you don't consider that really what you should be working on are things that are both important and urgent, right? And also the thing to keep in the back of your mind. So those are the things that are good to do first. But it's also important to keep in mind that, you know, a lot of legacy software and the legacy trap comes from that important but not urgent category. In fact, ignoring that category is kind of what sticks you in the legacy track, right? Like, it's important that you update your software. It's important that you make sure your software is fit, that it has agility to it. but it's not urgent enough that you go and modernize those things, right? So it's kind of living over there in the important column that becomes very important to think about. But as far as scheduling the first thing that you do, what you want to start thinking about to kind of think about how you weight these things is think about the technical feasibility as the y-axis here, right? So what is our ability to change this application or this service that we're looking to modernize, or just like all those services in your portfolio, like how easy would it be to change versus not easy, right? And then the next attribute that you want to think about is, let's call it the impact. This is the importance, to use that word, to your organization, to the business, right? And what you're looking for are those things in, as always with the 2x2 matrix, the things in the upper right quadrant there, right? That it's technically feasible to change them. So it's going to be easy to change them and update them. But it also will have, it's also important, it will have a high impact on the business. And what this basically means, to use more jargony terminology, is you want to find business-facing kind of business important applications that customers use or that help run your day-to-day business, but that are low risk as far as when it comes to the feasibility of changing them, right? And these aren't the only applications that you're choosing, but this is just determining what you do first, right? And this is often extremely important because the first thing that you're going to encounter when you're looking to modernize things is you're going to be overwhelmed by a huge portfolio. And if you're not careful, you're going to get stuck thinking over and over again about what you should do to just get started. And so following this, that methodology of figuring out what the technical feasibility is, and then kind of and crossing it in that 2x2 matrix with the importance to the business, it allows you to avoid this situation, right? You know, analysis paralysis will be, as people will say. And if you don't have a very simple and almost crude way of coming up with an answer of what to do first, you're going to end up in this stage of analysis paralysis where you're constantly going back and forth and not starting, doing analysis. This happens in all sorts of other parts of IT, where like you feel like you need to do everything at once, right? You want to go across this gorge in like the gigantic truck of everything. And what you instead need to do, and this is why I like this process so much, is come up with a model, with a way to choose the smallest things possible that make sense, right? To start slowly, not so much slowly, it seems slow, but to start slicing away at small pieces to kind of build up to doing things as a whole, right? You want to have like smaller things going across instead of getting stuck doing everything at once. But this is kind of the place that we start out with this process, is that if you're thinking that you're not going to do the first amount of actual work, of actual coding or refactoring or rewriting or just replatforming, if it's going to take you 6, 7, or 12 months to get to that point, you're probably stuck in this state of analysis paralysis. So let's look at how you can kind of think about what that looks like. And this is kind of like a more kind of thinking about how kind of like all those different types of R's and how they fit in there, right? So a lot of how people get trapped in a gigantic, big waterfall rewrite that just takes forever and runs up all sorts of risks of one cost, you know, the iron triangle of risks, right? The costs that you have are going to usually go over the features that you wanted. They might be delivered if you're just doing a one-to-one mapping, but you might find out that the features that you had in the old application are not really the ones that you need in the new application if you're just copying them one-to-one. And then 3, the quality of it may not be good, right? Because again, you don't have those tests and you don't have all the cases to go through. So, however, it's easy for organizations when they're doing this kind of strategy thinking to think that we're going to put all this time and risk and money into this effort, so we need to have a big payoff, right? The end result, the business case, as people say, it should be our most important application that is going to make us the most money, that's most important, because we're going to be spending so much time that we need to do that. Otherwise, we can't justify doing it. And this is some kind of toxic thinking that you might get from your finance people or the business side, where it's really important to them that on an annual cycle, you kind of pay off the investment that you've made. So you keep ratcheting and ratcheting up the promises until you have this gigantic bubble of a thing that you're going after. But instead, over here, these are the type of projects that we find are more successful long term, is that they have a good amount of business impact, and you're picking things out that you can start to show value, that you can show return on them in about a 3-month cycle or so, because this allows you to avoid kind of falling into this lengthy waterfall rewrite and also kind of getting stuck in analysis paralysis. And as I'll get into with the final example, also, what this does when you identify kind of like a 3-month window for delivering things is it allows you to learn not only what that application should be, but to also learn and explore what you need to modernize, right? Like you can make a lot of assumptions if you do a complete portfolio analysis in 6 to 12 months about what needs to be changed, what dependencies you have, what doesn't need to be changed. But until you actually start going in and modernizing things and doing the coding, you're not really going to discover all the dependencies that you have, the things you rely on, the applications that need to be modernized, the parts of the rest of your organization that depend on this. So you need some way of starting small to kind of almost, in a funny way of putting it, learning what needs to happen by, in a very controlled way, breaking things and exploring them, regardless of what you might have thought ahead of time. And so that's where, when you kind of identify these things that have a good feasibility to change, again, early on, that are lower risk to change, but have some kind of actual business value, you want to set yourself up in like at least a 3-month cycle to kind of deliver on them end to end. So that's how you start to identify the things that you'll be modernizing. Now, so what does this process look like? And then instead of going over kind of a definition of what each of these processes are, I'll kind of walk you through an example of a company doing this with their code base. So what the Swift process goes over is, again, it kind of takes its direction from a lot of what I've been saying, right? You want to figure out doing small, 3-month cycles or less of things, so that you're essentially learning as you're modernizing, right? You're not only learning what needs to be modernized, learning what the new features, what the business needs, but you're also learning the skills yourself, right? Often when you're modernizing things, you're moving it to a new platform. So like, you're running it on cloud, or you're moving VM hosted applitions to container based applications. Like you're moving from a more traditional 3-tier monolith way to running on top of Kubernetes or whatever, right? These are huge technological shifts that you need to learn essentially by doing, right? It's hard to predict how things are going to go until you actually get in there and start to do things. And that's why having this small window allows you to gather this feedback and learn not only about your application, but about yourselves, like how your organization is doing, what skills you need, and about what that process is going to look like as you scale up. And so you set yourself up with that cycle. And as I'll get into, you follow just a few simple practices that are quick to do to essentially figure out how to pull apart the kind of the monolith that you have, the existing application, and identify those little parts, those little thin slices that you can start to modernize, to start learning, but importantly also to just start doing something, right? I mean, again, to emphasize this point, if you're doing a modernization strategy and you've been doing it for 6, 8, or 12 months and you haven't shipped anything yet, you're probably doing it wrong, right? Like you're not doing as good as you could be, to put it another way. You're missing out on some benefits by doing it quickly. So the process basically identifies, as I'll get into, kind of like what the components are, and kind of rethinks a little bit about the architecture that you have so that you can figure out small slices to start doing. You generate a backlog, to use Scrum terminology for it, the plans that you're going to do. And you constantly go through this method, always evaluating if you've done the right thing, right? Always learning. And then you get to the point where you're just iteratively, whether it's in a 3-month cycle or, like a 6-week cycle, if you get, as you get lucky on a monthly, maybe even smaller cycle, where you're just kind of iteratively working on smaller and smaller slices. And eventually, once you've sliced everything, I guess it's kind of like a Theseus's monolith, where like as you change each little bit, it becomes a new type of application, a new type of monolith that you've refactored. So I'll give a reference at the end if you want to kind of walk through each of those, what those processes look like. There's great names in there like the Boris process and, doing event storming and things like that. You can kind of dig into what the mechanics of that look like, which I'll point you to at the end. But for reading through that, right, like seeing examples of how it works out, there's often not enough examples out there, in my opinion. So I just wanted to walk through before I wrap up a few of those, or one example that I think is a nice, no offense to them, but a good, boring, normal example of an application that was modernized. And this is from a pharmacy that I kind of mentioned this earlier during the COVID times. You can imagine if you're a pharmacist, if you're giving out prescription, well, I guess you're not giving it out. It has to be approved. You're providing prescription medication to people, and people, shift to being online. Like the whole way that what was once a very in-person business not only has a huge amount of requests, but the way that that organization functions, regardless of the software that it has, is dramatically changes. Like during the COVID time. So what this organization found was that their software was no longer fit. It wasn't performant, and also it didn't have new capabilities that they wanted to add. So they needed to very rapidly modernize their application, which had more or less been fine for a while, right? Like, again, it was in that category of important, but not urgent, right? It would be great for their software to perform better and have, the capabilities that would allow them to evolve how the business ran, but it wasn't necessarily urgent. But then it became important and urgent. And so I'll use them as an example of a little bit of how you kind of go through that swift process and think about things. So again, kind of pulling together a lot of what I've been going over. The first thing that you start doing is the approach you take is to think, all right, let's decompose kind of like this monolithic system into the business processes that we have. Like, never mind, I mean, obviously you think about this stuff, but don't just focus on like, well, here's the database and here's the eventing system and here's the front end. And, here's the authorization system. Here's the customer data system. So instead of having that kind of bottoms up thinking about the systems, instead, it's possible without very much time, like the workshops to do this, if you have the right people in the room, at most, they only take a couple of days to go through. But you essentially get some technical people in the room or online. Like we tend to use, when we do this with people, we use Miro boards, but whatever works, or an actual whiteboard if we're in the room with someone. But you have someone who understands how the business functions, who understands maybe some enterprise architects, if you're lucky, product managers or product owners, and developers, designers, kind of a good cross-section of all the people involved in this. And you start to think about, you do event storming, right? Which is kind of figuring out for workflows, for a process, an event that goes through your business, like I would like to get a new prescription, right? You kind of brainstorm as a group and think about all the little events that need to happen to make that happen across your system, right? And you represent them each with whatever it may be, a little sticky note or something. And then you go through a process of grouping them together into different, things get technical here with domain-driven development, but you group them into these, whether you want to think of them as bounded context or domains or subdomains. There's a technical way to think about all these things, but you kind of group them together into areas that make sense, right? And you can start to see how those different events that happen, and again, this is completely apart from how it's implemented in the system and the services that do it. You can see there's all these things that must happen for, just something that seems that's seemingly simple, verifying that someone can get this prescription, right? That there's not some fraud involved there. Or, if you're in, for example, a US based or other company that uses insurance companies, like making sure that they're covered by this, right? And on and on and on, right? So you start to decompose all these things for what seems to be a very simple process. And then once you have this, you can further break it down into the context that you have. And you're starting to get to kind of like an architecture that you can look at. And again, apart from the technology that you may have. And this is where, once you're kind of breaking things up into this kind of business architectural view, right? And that's not really driven by how the system looks like. This is where the technical role that people have, the technical people in the room, become very valuable, because then what they will go through what you want to do is, if you remember to that technical feasibility angle, what you want to go through is to think about, all right, so if we were to look at those different domains, let's think about if we look at all the parts of the system just to do one part of that, right? Like, let's say verification of a prescription, right? Like, what would it look like? What are all the parts of the system that one part picks, right? And you kind of think through, all right, it would touch this part and this part, and you kind of go through all the different flows that we were looking at there. And you try to find one of those that, again, is feasible and that you can deliver in a 3-month time period. And you say, all right, let's just do that part. Let's not do everything at once. Let's not modernize a subsystem or modernize everything at once. But what's the minimum amount of work that we can do to modernize that part of it? And obviously, it's a lot more complicated than just making a decision in a room and things like that. But that's the kind of decision you want to get through, where you pick one of those things that kind of has enough simplicity that you can do something with it. And then you do that, right? And in doing this, again, what you're going to arrive at is that you're going to learn a tremendous amount from going through that process. You're going to end up having actually modernized something. And very quickly, I mean, you're going to encounter all sorts of things you hadn't encountered. That's going to, if you remember back to that diagram of going through and evaluating, it's going to add new things to the backlog. You're going to be discovering things that now need to be modernized. And this process is also great because what you end up doing is you end up only modernizing what needs to be modernized, not only from a technology perspective, but from a business perspective, right? So you're picking these kind of threads, if you will, that go through. And in modernizing just one thing, like prescription verification, you only touch the things that need to be touched and modernized instead of just doing everything. So you get out of this trap of a one-to-one mapping of modernization. So then, what does this end up looking like long term? Now, I talked about 3-month things and starting small, but obviously in a large organization, you need to end up getting to everything, right? So you end up again in the initial phase where it's like the first month, the first 3 months, the 6 months, you're just doing a little bit and you're kind of coming up with what you're doing, right? You're doing a fair amount of this analysis, but also that quick analysis, going through, the event storming and the Boris, you can look that up, the analysis, the snap analysis, where you find these small slices that you can work on. And then you're getting to the point where you're transforming more and more of the applications. And I think how you scale that is it's launched by this notion of, by actually doing work, right? We're discovering things that need to be modernized. We're unearthing, metaphorically speaking, and we're finding out what needs to happen, right? And we're also building up not only the new skills that we need to modernize things, but we're getting better at identifying what needs to be modernized. And this is a very lean, agile approach that I think is good to take in all of software. Is like, if you find yourself trying to predict what you need in 12 months, it's, again, probably not going to work out very well because you're making a lot of assumptions about what you need, your skills and abilities to do it. You're just missing so much information. And instead, gathering more feedback as you're working on things generally pays off, especially in software. So there's a lot more details, right? Especially if you want to dive into what those various processes of Swift. And again, all of that stuff is written up pretty extensively, and there's a lot of examples out there. You can start to do these things on your own if it seems useful. And there's some links down there, a little QR code that will go to this stuff, but you can get for free the write-up that Mark and I did with the legacy trap here. And another little bonus thing, this is more in the area of doing platform engineering or setting up platforms, but it's also a good way to start thinking about not only how we would modernize our applications, but a thing that you encounter very quickly that I didn't go over at all is, how do we modernize the way that we work? How do we modernize our organization, the processes, the culture, if you will? And that modernization, you'll find very early on, is also required if you want to modernize how your business functions, how your organization works, even modernize your software, right? And a great way to get started with that, I think, is to do what we call a developer toil audit. Again, something that you can do all on your own. And essentially, if you're thinking about modernizing your organization, what this is all about is going to the developers and using a way of surveying them to ask a series of questions that helps you discover the toil that they have, the things that you could modernize the processes, the organization structure, the tools that they have, even in that grandest sense of the word, the culture that they have. And you can start to figure out, again, you can learn and iteratively work on modernizing the culture that you have in the place there. So I'm also pretty easy to get a hold of if you have any questions ongoing. But hopefully this is giving you an idea of how, if you find yourself stuck in the legacy trap, how, it's a lot of work. It's not easy, but how you can start to get your way out of it by actually doing work there. And so I'm happy to take any questions if there's any before we wrap up. So let's see. I think.
Yes, hello.
Yes.
So thank you very much for your speech. We do have some questions. So I will start with the one, how can you calculate the business value of modernizing a legacy system? Can you calculate the business value for that?
Yeah. So there you go. See, that's the only question really, right? Because I think in asking that question, the questioner understands why it's difficult. And so, yeah, I think, to go back a little bit, right? So so first of all, there is a huge answer to that question, which is like, yeah, that's really hard. However, there are ways of getting around it. And that's where these S's can come into play, right? So I won't go into each of them, but so the easiest way to do it is that if you don't have fitness, right? Like the application goes down, in a retail environment, we lose out on making money, right? So you can kind of calculate because it's not fit and it won't perform, we lose money because we just can't sell stuff. But not everything is that easy. Now the next thing to think about, you can think about each of these things, how there's an opportunity cost, how if you had more speed, you could do more, right? Like if you had more, as I was going with, more stability and more scalability, you could add more customers, right? You could support more of a load. But I think one of the more clever ways of thinking about it, which takes a little bit takes a little bit of crafting, if you will, is that speed part. So if you say, if we can deliver more software frequently, we can deliver software more frequently. This means that on the business side, you can start to change the way your business functions more frequently, right? And this means that you can start to pursue new ways of doing business. You can get into new markets, right? So that's why I started out with that example of insuring phones at the beach, right? So you can kind of say like, well, it would take us 6 or 12 months just to do that. But what if we could do those kind of businesses instead in like 3 months, right? And so what we have there is we can start selling that. We can start selling that offering a lot more sooner, so we can get the money sooner, right? Now, again, this takes kind of a lot of crafting, but it's the kind of discussion that I think hopefully you could have with the business side people to essentially say like, well, what if you could sell more, have new types of businesses that you entered into? You could have new types of accounts types in banks or new types of things like that. And that's a lot of how you can't really put that in a spreadsheet, but you can start to use that as a model to think about appealing to people who are just worried about like, how's this going to make me more money? And kind of have a very, unhelpful view of these things.
Okay, thank you. We do have questions. The next one is from Andrea. Who can decide which is the right slice, the architect or the senior developer, or should it be a team decision?
Well, I think, what I've seen in general is that you drive it by a team, essentially, right? Which drives the next question: who's on the team, right? But I think what's important is definitely not to have just one person, because if, as you've hopefully picked up, right, a lot of what you're looking for when you're doing this process is to iteratively put in place a learning process, right? And definitely if you just have one person, you're not going to maximize the learning that you have, right? And also, unless you're a very small organization, in which case, like I said earlier, you probably don't really have these problems as much. Like one person isn't going to know enough of everything, right? So like, you're going to need someone who has business input about the value of something, right? You'll need to have those kind of like senior architects who have like a tops down view of things and kind of know all the different systems. And then you're going to need some developers who also know that like, well, I know our diagram says it does this, but it does not, right? Like, you know, someone who actually knows the way the components work. So, you know, that's part of, I think in general, when you have the big kind of meeting to slice everything up, you obviously can't have tens and tens of people in there, but you want some representation from kind of across the area to kind of start to break it down. And then as you get closer and closer to the slices, again, you want to have some developer types, some architect types, and however you represent the business in the room. But if you have it be on the shoulders of just one, you know, your wizard enterprise architect, just like, I don't know if you've watched all the wizard movies that I have, but I would not like to be a character in those movies. Like, bystanders tend not to work out well when wizards are around. Things go terribly. It's better to have a very boring movie with lots of people in it. I'm not sure if that joke worked out, but I tried.
The next question, Flavio asks, when modernize a slice, the rest of slices should receive info from the new slice in a way, I heard about any corruption layer, but never use it. Not sure if this is the solution. Do you have any documentation on how this integration can be done?
Yes. So there are many patterns. So you've identified one of them, the anti-corruption layer. There's another pattern which is very famous, the strangler pattern, which fortunately is named after plants, not like I guess Halloween's past, not murderers or anything. But there's actually a good collection of patterns that are used for modernization. And I think we referenced them. I'll have to go update the page to point to these patterns. But yes, there's a lot of patterns built around exactly what you're identifying, is that when you can't change everything at once, you need to put in a lot of, I always think of it as silly putty code to kind of account for the older stuff working with the new things. But you're in luck. People have been doing this for a long time, and the patterns are extremely well documented. And if you're like in Java development, for example, a lot of the stuff that's in the Spring framework can help out with this. It's just kind of built into it. But I'll try to go back to that web page I referenced and add a link to that.
Mihai asks, what should we do for getting the buy-in and commitment from stakeholders to start to modernize?
Sure. So this kind of builds on the making the business case part, right? So I think depending on who the stakeholders are, right? So let's take two types of stakeholders. Let's call them like your friends, the technical people, and then like those business people over there, like those stakeholders. And I think when it comes to your colleagues, right, other technical people, I mean, I think the main way to get buy-in, to get enthusiasm, is to focus on how this will make their, I mean, it sounds kind of whatever, but how it will make their lives better, right? Like, as I was saying with the Shine thing, like, people don't really like working on old stuff. Otherwise, they would just call it their software, right? And so kind of illustrating to them that like things are going to be better, if not only more interesting, if we do things this way, right? That your job will actually be better. Now, there's a special case of this, of someone might feel threatened, and it might seem like it's going to be a lot of extra work for them. But usually, and this is usually like compliance people that you might be working with, usually when you're modernizing the way that something like compliance or even performance is done, what you find is that by modernizing it, by using newer technologies, their lives improve as well. They have to do less work after hours or on the weekend to put up with things. So really, when it comes to your kind of peers, kind of focus on how it makes their lives better. Now, also what you need, and this is why it's important to start small with like a 3-month project or less, is you need to build up success cases of working within your own organization, right? So, you know, you can go in there with my funny little pharmacy example, but people will if people don't want to change, they'll just say like, oh, that's some other organization. We're unique and have our own problems. So like, you need to somehow initially start with 1 or 2 applications that have been successful. And these might be small applications. You'll have to kind of, as we used to call it, do a skunk works where you carve this out, but you've constantly got to be marketing, no matter how small it is, that in your organization, you've done something successful and you can kind of point to that as success. And then on to the business stakeholders, that's where these applications become incredibly important. And that's why selecting applications based on their business outcome being used by customers or citizens is important. Is some of those initial applications, they need to show that they have improved the business somehow, right? And so as you're selecting applications, it's important to pick applications that you're going to be keeping in mind that we're going to be talking with business stakeholders, and we want to show them that we improve the way the organization functions by modernizing it. And I'll give you one small example that I often recommend to people over the years is, as an example of one of these types of applications, picking like a store locator application or like an ATM locator application. So these are great examples to think of because often they're neglected. They don't really do very much. They also don't involve a lot of customer data or really anything mission critical, right? So you're not going to have to go through compliance and regulatory and security stuff to modernize them. But if you think about it, like finding a store or finding an ATM is incredibly important, right? And so what you can start to show is like people are actually using this more successfully. They're finding the stores, the hours they're open. This is pretty directly driving more business, whether it's banking business or the customer experiences people have with an ATM locator, or it's making sure that they come to a store, like, you know, whatever it may be, right? So think about those for initial applications that are simple. And then when you're going to broaden that scope, you're kind of going up that curve of scaling it up. You'll start to build up more and more of these cases where you can show that doing all of this work is actually improving the way that the business functions. So start thinking about that from the beginning as you build this up.
2 more questions from Radu. Have you worked on revamping an old COBOL application? If yes, what were the major challenges you found along the way?
So I haven't worked on it firsthand, so I can't really give you many details. But yes, this process has definitely been applied to COBOL applications, and I think, you know, I'd have to get back to y'all on this if you want to email me or contact me. But I think there is a pretty normal set of things. I mean, the biggest challenge is just like lack of knowledge that you're getting over. But yeah, I mean, this process can definitely be used for that. I unfortunately don't know the firsthand issues for it. But yeah, if you email me, I can track that down for you.
Okay, so Radu, you can email Michael. And the last one, what is a realistic time estimation for modernizing a legacy system that took 10 plus years to be built initially?
Yeah. No, I think, you know, the honest answer is like, who knows? But I think that's why, you know, that's why it's important to figure out these slices that you do and just doing little parts of it here and there, right? I mean, the issue is like, you know, a system that has taken that long to build is probably tens, if not hundreds of other systems and types of things that, you know, different use cases that you have and scenarios and probably different geographies and countries that you're working in. Like there's probably companies that you've acquired. So like, you know, it's going to be a big system. And so that's why it's important to kind of like slice off little parts of it. Like I remember one system I was talking about with someone recently that was, I think, a tax collection agency in some government. And as you can imagine, I think the tax collection agencies are some of the earliest users of computers ever, right? Like basically government agencies that have to do something for every single citizen generally is where a lot of programming started. So modernizing that is difficult, but they had a very interesting approach where they realized that collecting the taxes could be a completely separate process than processing the taxes. So they were able to rewrite, again, you know, you think about submitting your taxes, you just submit it and you hear back later. So they were able to modernize that part of their application and run it in public cloud. And they could collect it all. They did the application, they could collect it all in the public cloud and then just send it to their older system for processing, right? And so you know, with these very old systems, you think about where are these points that we could kind of like do that kind of breaking off of it and improve part of it to get us well on the way of improving the rest of it. And then also sometimes there's just parts that you leave there. I mean, again, you know, people in my part of the industry, we're always very excited when people want to migrate from a mainframe, but sometimes the mainframe works, right? Like the components of it work well together if you can maintain the fitness of it. But that's what I would do, is kind of find parts that you can pick off instead of worrying about describing all of it. And that's also why, like, who knows how long it'll take? Maybe it'll take forever and it'll never be done.
Okay, so these were all the questions. If there are no other questions, then thank you very much, Michael, for accepting our invitation, because as Julia said at the beginning, we base our conference on invitations. We personally invite speakers and talk to them, and thank you for accepting to be here. We really hope you you like the questions. We have a big round of applause.
Yeah, no, and I really appreciate being here. And those are great questions. They were nice. It's always good to have a question I can't answer too, because now I have something I want to find out. But yeah, that was good stuff. I really appreciate it in the questions. Thanks for having me.